Hello and welcome to the ICS 103 programming course, and today we'll be talking about data files. Okay, so let's start. So what are data files? Data files are a way of saving data into a computer. What do? Is we create a file, and inside the file we write information, and that information is stored into the computer. This is what a data file is basically. So we can, whenever we want it, we can retrieve it, so we can look into it and then change it maybe and then save it again. This is what we do when we are working with word processors. When you type some side of an assignment or a letter that you want to write, you go and actually write something and then you save it. That's basically called a file. Okay, so until now we're working in programming in C, and in all the programming that we have done, what we have done is taken the input from the user. Okay, so every time whenever with the program we're working in, we ask the user to give us an input, and then the user inputs it using some input method just like a keyboard, and then we display the output to the user using a screen. Okay, so this is what we have been until now doing. Okay, however, in real time, in real life applications, basically the inputs are usually not taken from the user always. Okay, so imagine that you have a company, and the program you are making is going to be for the generation of the pay slips for the employees. It's going to be tough that every time you ask the user to enter the employee name and his salary so you can actually generate a pay slip for him. And thus what we usually want to do is we want them to sit with them once, get the employees and the salaries once, and then we want to take this data and save it into a file so that in the future when the salary comes, we can just open a file and read all the data and then process the pay slips, for example. Okay, so most of the applications usually do not require much interaction with the user. They want to take things from the database, from a data file or something that has been stored previously and then worked on it. Okay, and the good news is that C actually allows us to do that. Okay, this example is in the program that generates a payslip. How can we print the payslip and distribute them to the employees if the output is printed onto the screen? Okay, if your output is printed onto the screen, you're using just one output, we cannot distribute anything to it. You have to actually send the output maybe to a printer or maybe as an email, so they get an email as a payslip. So different type of outputs may be required. Okay, it's not always that we work with the screens. Okay, so programming in C actually allows you to do data files, and data files are going to help us in this regards. Okay, so in data files, there are three things that we have to do in data files. Whenever you're working with data files, there are three steps that you have to do. The first step is actually you have to open the data file. The second step is you have to work with it, so you read and write to it. And the third step is to close it. This is how you actually work with data files. Okay, now to declare the variable of the data file is the first step. So to open a file, what do? Is we declare a variable of type file. Okay, this is a special variable type. It's called capital F, capital I, capital L, capital E, file. Okay, and this is a variable that you have to declare, just like the int, the double, the character. This is a variable type. You're going to say file and then put the name of the file that you want to name it. Okay, so you have to declare this variable first. As soon as you declare this variable, the second step is you have to open it using a command of open. You use the command fopen to ask the compiler to go and open that file for you so you can actually read or write data to it. Okay, after you have opened the file, you actually use the fscanf or the ffprintf to read and write from the file. So if you wanted to read from a file, you use the fscanf command, and if you wanted to write to a file, you use the fprintf command. Once you've finished working with the file and you have read and written whatever you were doing with the file, you have to issue a command called an fclose. In the fclose, you basically ask the compiler to go and close that file. That means that you are not going to be working with that file anymore. You cannot read from it, you cannot write to it. You are telling it, hey, I have finished, please close this file and put it away. Okay, so we're going to be talking about this, and we'll be going through some examples and to clarify this concept and the steps that we take. Okay, but before we go to an example, let's look at the specific commands on how they actually work. Okay, So when we want to declare a variable type of type file, this is how we do it. We write capital F, capital I, capital L, capital E, file, okay? And then we put the star, say, because it's a pointer type file, and then we give a name of that variable, okay? So over here, for example, it's in file. So the in file is a pointer variable, and this variable may be used to connect to a file. So what actually happens is, inside your hard disk of the computer, you will have a file, okay? And that file might have some data, and this is the data that we want to read. So we declare an in file as a pointer. So this is our main program. We declare a pointer over here that can actually point to this file. That is why we have the pointer over here. And what will happen is that this pointer is going to be pointing at that file so that we can actually read and write from it. So files basically stay in the hard disk, okay? And whatever we want to put them in the hard disk so we can retrieve them later. Whatever is in our memory, which is the RAM, we can't actually use because whenever we close the PC and come back, the RAM is deleted and reinitialized, okay? So that is why what we want to do is write it to and read it from a hard disk. That is why we have a file pointer type, so we can actually ask our program to point to it, and then we can read and write from it, okay? Now over here we also declare another file type of type file. It's a pointer and it's called the out file, so we basically have two pointers. We might have another file over here, and this is pointing to that file, okay? Now note that we are using a pointer. This is not a variable file, it's a pointer, and the reason is that we want to create the file into the hard disk, and we want something in our program pointing to that file so that we can actually go write and read from that file, okay? So this is used to indicate that the variables are pointer variables. Notice that the pointer variables, they are not normal variables, they're pointer variables, and we shall learn more about these in the coming few slides, okay? So opening a file. What do we do in opening a file? In opening a file, we use the command called fopen. So when you want to open a file, you need to know the name of the file, okay? So if you want to read a file, if you want to open a file that you want to take data from, you have to know the name of the file. It's just like us human. When I tell you, bring me something, you have to tell me what do I want to bring. So now I'm going to ask the computer to go open a file so I can read from it. I have to tell it which file are you going to be opening. So let's suppose that we are going to be opening a file, data.txt, to read from it, okay? So this is how we're going to use the command. We're going to say the in file is equal to, so we're going to assign the in file variable that we declared. So in the previous example, in the previous slide, sorry, we declared the in file. We're going to go over here and assign that in file, the pointer variable, a value that is going to be given by the function fopen. The fopen function is going to open that file and give it to you. And the fopen function takes two variables or two parameters in it. The first parameter is the name of the file, and the second parameter is what type of file is this going to be. So when we have an R as the second parameter, that is indicating that I want this file for read, okay? So it's a read-only file. You cannot write into it. You can take data from it, but you cannot write into it, okay? So the R is indicating that it's a read file, so the compiler is going to go and look for a data.txt file. Now, where is it going to search for this file? It's going to search for it in the same folder the exe is running in. Okay, so the exe is running in the same folder. It's going to go and search for a data.txt. And if it finds it, it's going to open it for read. So the in file will be assigned a pointer value so it can actually point to that file. Okay, now once opening a file, there are two cases. One case is, hey, we found the file, so the exe and the data.txt file were in the same folder, and we found it and we opened it and we assigned the in file a value that is actually the pointing value, so that can actually go in to the hard disk and read and write. Sorry, read only, because we open it as an R. And then we the other case is that if the compiler was not able to find the data.txt file. So what's going to do? It's going to return a null and assign it to the in file. This is the way for the compiler of telling you, hey, I tried to open this file, but I couldn't find it. So you told me to open a data.txt file in the folder that I am in where the exe is running. I didn't find this file, so that's going to return a null for me, okay? Now the R is for a read. You can actually change it to a W, that is for a write, okay? So to open a file to writing, for example, you want to write the result, you did some calculations and you want to write the results, you can open a file called result.txt, and to open that file for a writing purpose, this is how you do it. So you do out file is equal to fopen result.txt and W. So the out file is the pointer variable that we have declared previously in the previous slide, and the fopen, you're asking it to open a file. Now notice the W means that I want you to open this file for writing. So as soon as the compiler sees this, what's it going to do? It's going to go in the same folder that your exe is running in, and it's going to create a file called result.txt. Okay, so it doesn't have to exist over there. If there is nothing, it's going to create this file for you. Okay, and then that file will be empty. You can start writing data into it whenever you want. Okay, in case that file was there, okay, any data that is in it is going to be deleted. So what basically the compiler does is goes and deletes any file that is of the name result.txt, and then it's going to recreate it for you with an empty. So whatever is inside that file is going to be deleted. That's how we view it, okay? So if the operation is successful, you will return with a pointer variable that is going to be pointing to the file that you're going to be writing to. Now, it might happen that it's going to return with a null, and a null means that it's going to assign the value, the out file, to a null, and that basically means that the compiler was not able to create this file for you. Now, there might be multiple reasons that the compiler was not capable of creating the file. One reason might be that your hard disk is full. When your hard disk is full, the compiler is going to go and it's going to create the file, but the hard disk is full. It's going to return for you a null, says, hey, I couldn't open this file because there is actually no space in your hard disk, okay? Another example is you might be using a user that doesn't have a privilege to create a file. If you are not privileged to create a file, the fopen command will return a null for you, and then you can actually detect that in your program using an if statement, and then do the appropriate action that you want to do. Maybe inform the user, say, hey, you don't have, I couldn't open a file, please check your privileges, or whatever the result you might want to show, okay, to the user. But most often, when using a W, if you have the privileges and you have a hard disk space enough available, it's going to return for you a pointer variable that's going to be pointing to the file that you're going to be writing to, okay? So, most important with the W, if the file does not exist, it will be created. If it exists, it will be overwritten. What does overwritten means? Whatever is inside it is going to be deleted, okay? So it's going to delete whatever is inside it. So be careful when you're using a W with a file. If you had some important data into it, excuse me, so it might actually delete the data that's there. Now, after you have opened a file, let's suppose that you have opened a file, one file for a read, one file for a write, okay? So the data file was open for a read. Now we want to read from it. How do we read from it? We use a function called an fscanf. And the fscanf function is similar to the function fscanf. The only difference is that we have one new parameter at the beginning where we specify which file I want you to read. Now, remember, the compiler, for in our previous example, we opened two files, one for read, one for write, okay? So we have to tell the compiler from which file you have to read. So we say from the in file, please go read for me a double number and put it into a variable called miles, okay? So this is basically exactly as the fscanf that you guys have already learned. And this is the only new thing. This is the file in which we are reading from. So the fscanf requires you to give it the name of the file that you want to read from and the address of the variable you want to store using the fscanf and the type that you want to read. So this is just like the fscanf, and you just give it an extra information of where to get this file, okay? So suppose you read this from a file and you get the address of miles, and now you want to do a calculation and convert this miles to kilometers. So you're going to be using some sort of command just like this and multiplying by the constant that is converting the miles to kilometers. And then once you have computed the kilometers, suppose now you want to save it into the result file. To save it into the result file, we use an fprintf. And the fprintf is similar to the printf. The only difference is that you have to specify the file in which you want to write. So this is the files. We tell it go to the out file. The out file is a pointer variable pointing to the out file. So it's going to use that variable, go to that file, and write into it whatever we give it over here. And this is similar to the fscanf. Oh, sorry. This is similar to the printf command that we have already learned. So it's going to go and write the string, and instead of this percentage point 2f, it's going to take the value of kilometers, approximate it to 2 decimal places, and place it over here. And that's what's going to be written inside the file. Okay? Now again, the fprintf function is very similar to the printf function, except for that fprintf needs to know which file it has to write into. Okay? Both the fscanf and the fprintf are in the library stdio.h, so please make sure when you use them to hash include the stdio.h library. Okay, now the third and final step that you have to do with the files is basically close the file. So when you use a file, you open it, you do whatever you want, read and write operations into it, and then you have to close the file. To close the file, you use an fclose. Okay, so the fclose is basically a command telling the compiler that, hey, I have finished with this file, close it. After you close the file, you cannot read from it, you cannot write to it, you cannot do anything to it, it's gone. If you want it again, you have to reopen it using an fopen. But the fclose is a very important command telling the compiler, hey, I finished with this file, please close it, let it go. Okay, so this is how you write the command fclose. In between brackets, you write the file pointer or the variable of the file that you want to close. So fclose in file will go and close the in file, and fclose out file will close the out file. Now, it's very, very important to close a file if you have opened it, okay? I'm going to explain this into the next slide. So suppose you have a program. In your program, you want to open scores.txt, and this is scores.txt, okay? So it's actually shown over here. This is scores.txt, and you want to open it for reading, and there is a 123 text, and you want to open this file 123 so you can actually write into it, okay? So what happens when you actually open a score.txt? We said you will have an in file over here, okay? This is a pointer variable, and this variable is going to be pointing at the file that is in the hard disk. So this is the file that is in the hard disk, for example. So you will have an in file, a pointer that is going to be pointing over here. Now actually, that's not true. You don't point actually to a file directly. Why? Because the operating system, the operating system is the one who handles files. So what does the operating system do? It actually creates a buffer for you. Okay? A buffer. What's a buffer? It's a place where you can store things temporarily. Okay? And the in file is going to be actually pointing to this file. When you do an fopen command, what happens is it goes and actually opens the file and creates this buffer for you. When you read from a file, when you use an fscanf, for example, and say read from the in file, it actually reads the value that's over here and writes it into the buffer. So it's going to write 1.5 into the buffer, and then you will read it from the buffer and then go back, okay? So you do not go actually to whatever is in the hard disk. You basically are inside your main function and reading from the operating system buffer. This is actually what's happening. Okay, so the next time you read, it's going to copy all these numbers over here, 3.5 to 10. So the next time you're going to read this number. The next time you're going to read this number, you're going to read this number. And remember, when you read from the buffer, it's going to delete the numbers after you have read it. So you can only go forward in the buffer. You can never go backwards. Once you've read it, You have read it. That's it. You bye-bye. You cannot go back to it. If you want to go back to it, you have to close the file and open it again so that it can actually go from the start, okay? Well, actually, there is a function called rewind, but we're not going to teach you that function. So in your case, you cannot go back once you read a number, okay? So this is what happens in the file when you open it for read, okay? Now, if you don't close the file, the operating system doesn't know that it has to delete this buffer, okay? So when you open a file for a read, it doesn't create much of an issue except for some security issues that might have occurred, that this is going to be hanging after your program is closed. This buffer is not going to be deleted. If you do not close this file, this buffer is not going to be deleted, and it might create a risk and a threat, but in a read, usually the threat is very low. Okay, now let's come to the example when you have the 1, 2, 3. So you have an out file over here. Okay, now this is the output file, and you want this output file to actually point towards this file here that is shown over here. But what the operating system would do, it's going to create a buffer for you. Okay, and you will be pointing at this buffer. So whenever you come and say fprintf, let's suppose we're going to be having 3 commands: fprintf1, fprintf2, and then fprintf3. Okay, so we're going to be entering 1, 2, and 3 into the file. So suppose you put 1, so it's going to come over here and put 1, and then we put an enter, a /n, then we're going to put 2, then a /n, then a 3, then a /n. This is what we inputted in our program, okay? Now, the operating system does not go, as soon as you put this and you put an fprintf command, it does not go and write everything that is in the buffer into the file, okay? It waits until the buffer is a good size, and then it takes the entire buffer and writes it into the file. Now, if you write into the buffer and you forget to do the close fout file, okay, you forget to do that, what's going to happen is when you close your program, the operating system might delete this without writing this to the file. So if it doesn't write it to the file, your file will be empty. So next time when you open the file, you open it and you see there is nothing in it. You say, hey, but last time I made the program and I asked it to write 1, 2, 3. So I was expecting to have 1, 2, 3 over here. But when I open it, there is nothing. What happened? What happened is you forgot the fclose, because the fclose basically tells the operating system to go put whatever is in your buffer, to flush it, to actually write it down into the file so that the information will be there at the end when you go and open it next time. You can actually find it. Otherwise, it's going to be in the buffer and the operating system might not go and write it, okay? It also puts something called an end of file character at the end, so that when you do a fclose, the end of file character denoted by EOF is actually put. This is something that you cannot actually see, but it actually tells the compiler, hey, this is where or it tells the computer this is where the file ends. There is no more data after this in this file. Okay, so this is what's going on. So this is why we have to use the fclose. So it's a common error to forget the close file instruction. Okay, it creates problems specifically with the output files because of the buffer that I just explained. So the operating system may delay writing data to the output file. Why? Because the hard disk is very slow compared to the RAM. So the operating system, to make it much more efficient, it collects all the data and then writes it once. And that is why you might, if you did not close, you might have data into the buffer that you're not going to be flushing, or you're not going to be putting into the hard disk, and you will lose data. That is why we stress on the fact that you have to close a file. It is possible for a program to open a file for output, print some result, close the file, and then open the same file again as an input. Okay, so if you close the file, you can open it, and then you can open it as an input or an output file. Whatever you want to do is capable you're the programmer, you decide what you want to do, okay? So let's go on and take a real example. So here is an example. In our example, what's going to happen, we're going to be taking an example where we convert the miles to kilometers, okay? But this time, the input is going to be from a file, not from a user, okay? So what we will do, we will write our program, and in our program, we declare our double miles in kilometers as always. Now notice, this is the new thing. Files, in file and out file. We declare two files, variables, pointer variables that are in file and out file. Then we're going to open the first file, the data.txt. So the data.txt is the file that has the number that we want to convert to miles, okay? And then that's why we're going to open it for read. Now, that file might be created by someone else, and we don't want to change that number, so we're going to open it for a read. My program is going to be outputting in a file called result.txt. That's why I open it as W. So we use the fopen command for the out file for result, and we mark it as a W, so it's going to go and create that file, and it's going to be waiting at the beginning of the file so I can actually start writing to it. Then I'm going to use an fscanf, and I'm going to go to the in file and read for me a number and save it into the variable miles. So we have a variable miles over here, and I'm going to ask it to save it into the variable miles, okay? So it's going to go to the file, read the first number, and put it into the variable miles, okay? Then you can actually echo this to the user, so you can go into the to the output file, and you say in fprintf. So now you're asking it to write to the file. Which file I'm going to be writing to? I'm going to be writing to the out file, and you're going to write it into it. This distance in miles is, and then you're going to approximate it to 2 decimal places, the miles, and put it in, and then you're going to be opening a new line. So inside your file, okay, your file, when it starts, it's going to start writing over here the distance, and it's going to write the entire line over here with the number inside it, and then the cursor, we're going to come over here and start waiting over here because I have a /n. So it's going to put the number, whatever number it has written. Oh, it has read in the miles, okay? Then we actually, this is, by the way, this is what we call echoing. So we read something from the file, and then we echo it into the output file so that the user knows what was the input and what would be the output, okay? Then we go and calculate how much miles, how much kilometers is this miles by multiplying it by the by the constant of 1.609. And then we go and say fprint into the out file. So I ask it to print into the out file. So over here, the cursor is waiting over here in the output file. That equals to, so over here, it's going to write that equals to, and it's going to continue kilometers, and it's going to write it, okay? So this is what's going to be written to this file. Then notice we close the in file, so whatever file, the data.txt we were reading, it's going to close the data.txt file. Now we cannot read from that file. And then we're going to close the output file. And when we're closing the output file, we're asking the operating system to go please flush all the data into the file and put the end of file character inside the file, okay? And after that, we have the return 0, so our program is going to stop. Now note for this program, to run this program, you need to first create a file using the text editor. So use any text editor that you have and name it data.txt and put the data or the number that you want to convert into it so you can actually convert it. And you have to name it data.txt. So the name of the file has to be exactly matching the name that is written here, okay? This is very important, okay? Now, echo versus prompts. So echoing, what is echoing? Usually, in the last example, when we have used the fscanf, we got the value from a file. We want to put the value into the output file so that the user, when he opens the file, he knows what we have read, because we didn't show that to the user. We want him to see, hey, this number was in the file and we converted it. The miles was this, and this is the kilometers we're going to do it. So echoing is basically something like copying. So we copy the input and we put it in the output so that we can actually show him what we were working on, okay? The program input comes from a data file there is no need to proceed this statement with a prompting message. Instead, we follow what we call an fscanf with the statement. So we print to the user the miles, okay? Because we don't want to display it onto the screen. Now we're writing it into a file. That's why we're echoing the miles into the using the printf into the file. Okay, so if we do not do the printf, okay, the user will not know which value we have read, okay, and the scanf. So that is why we have to do an echoing, okay. We don't prompt, okay. The user for the input, we actually read it from the file and then we echo it into the output file so that the user knows, okay, this is the number that I converted to kilometers. So whenever you read input from data files, make sure to use echo print instead of prompting, okay? Don't ask the user to input. You read it from a file, just print it into the file and say, hey, this is what I read, and then you basically convert it so that the user knows that these are the numbers that are actually being printed, okay? So here's the example. In the same example, you can see we have read over here a number in the miles, and then we echo printed it into the file, the output file, so that we tell the user, hey, this is the value I read, and now I'm going to convert this value to the miles, okay? Now, handling files if the file was not found, if an error occurs, okay? So if an error occurs, you have to handle the error, okay? So for example, if you do an fopen, so the fopen, you tried to open a file for read, and then you were not able to, or the compiler was not able to read that file, or to find that file in the same folder, so it's going to return for you a null. Once it returns a null, this is creating a problem for you. What's going to happen in your program after the read, after the open, basically, the first thing you're going to do is read from a file. And when you try to read from a file, the compiler was not able to open it. It's going to throw an error when it's reading. Say, hey, you're asking me to read something in a file that I cannot open, okay? So you have to handle this error. So after the fopen, what we usually do is we check if the in file is equal to null, okay? So after we do an fopen command, we don't know whether the compiler or the computer was able to open this file. So we check, we say if in file equal to null. If we find that the in file is equal to null, and notice this is a capital N, capital U, capital L, this is a constant that's defined in this std.h basically. If this value is reached, it's a null, we couldn't open this file, we print to the user, sorry, input file was not found, and then we say exit 1, okay? Now, exit 1 is a command that's going to tell the program to terminate. It's just like the return 0. The difference between return 0 and exit 1 is that the exit 1 is telling the operating system, hey, or the user, I exited with an error because I have detected that I could not do something. For example, over here, I detected that I could not open a file, so I print this to the user, and I say, hey, error, I could not complete my program. So you use exit 1, okay? So this is basically how you check. So after every fopen, you should put an if statement where you check if it's equal to null. If it's equal to null, you print an error message and you exit your program. If it's not null, if this was if the opening was successful, the compiler is going to come check this condition and it's going to jump out because it actually was capable of opening, and then continue your program normally, okay? So make sure that if your compiler was not able to jump over the cliff of opening a file and it falls down, that you handle it. You have somewhere where it can actually stand and then tell the user that, hey, this is what happened. Don't just crash your program and then exit without telling the user what's happening, okay? Exit should be called with an argument of 1, okay? That means that you have an error, that's why you're exiting. This results the operating system that the program stops due to an error. It tells the operating system, hey, I'm stopping, but I'm stopping due to an error, not because I have finished my program and successfully done what you want, okay? 0 is used with return 0, and 1 is used with the exit with error. You can actually pass any value, and then the operating system can if you want, in the advanced programming, you can handle those errors and then do whatever you want with it. Okay? So now let's adding this error handling in our program. So in our program, you remember we declare the variables, okay? So we declare the variables over here. We have the files, and then we open the in file. After we open the in file, we put this code over here. We check if the in file is equal to null. If it's equal to null, I'm going to be say error, and then I'm going to exit, and the program is going to stop here. It's not going to continue. As soon as it hits an exit, the program stops, okay? If it was successful in opening the file, this condition will become false. When this becomes condition false, it's going to jump from here, go to this command, and it's going to continue your program as if nothing has happened, okay? So this is a check. You check if the file was open or not, okay? So it's a good way of checking it over here. Oh, sorry, it's going to come over here, not over there, because this is the line that is after the if statement, okay? So it's going to continue after the if statement as if the program is normal, okay? You should check even after the output file fopen, okay? So out file is equal to fopen. You should actually copy this code after the out file also and change the in file to an out file, so that if you were not able to open a file for W to write on it, then you can actually stop your program also, okay? Now, remember, we talked about the end of file character. Each file that we have has a special character at the end called the end of file character, okay? The end of file character indicates to the computer that this file, the data that is in this file, has ended. So you have to place this end of file character inside each file. So a common application for data files is where the input data is large, okay? So whenever the input data is large, tomorrow you're going to be graduating hopefully and working in companies. Companies usually have large datas, and you have to work with large files, okay? So finding, for example, finding the average of a class from grades of students in a quiz. This is an application that might be required from you to read a data from a file and then calculate the average, okay? The grades are normally stored in an input file, and the program needs to read them one at a time and loop on them until all the grades have finished, okay? Now the problem is that you might not know sometimes how many students are there in the class. So if you are making this for a university, for example, for KFUPM, or you're making it for any other university, you basically don't know how many students will be inside each class, so that creates a problem. You cannot make a counting loop, and then you can actually count the people, okay? So the question is, how many times should the program scan the file and read from it? Now, if you exactly know the number of students, then it's pretty easy. You can make a counting loop, and then you can put a scanf or fscanf inside it and read it every time. But this will require you to know the number of students. What if you do not know the number of students? Okay. The good news is that the fscanf returns a special factor called the end of file. So inside the file, when it starts reading the file, if it reaches the end of the file, it will return for you an end of file character. Okay, so EOF. The EOF character is basically indicating, hey, the file has ended. I have read the entire file. Now this makes it a lot more easier. If you make a file that only has the grades of the students, you can still read the grades one after the other until you hit the end of file. Once you hit the end of file, you know you have finished all the grades, and that's it. You can then calculate the average. Okay, we can take advantage of this by using it as a condition. Okay, so we can put this as a condition into our loop, and then we keep on reading from the file until we can actually detect the end of file and then stop and then do the calculation. Okay, such loops are commonly called end of file controlled loops. So this is what you are going to be learning in the next. Okay, so basically files have in them characters that usually are not printable. Okay, so this is an example. This is a file. Okay, this is an example on the top. This is the file that is usually we see on our screens, and all the control characters are usually hidden in it, okay? So just like the /n that we put and everything, a tab, everything is actually hidden. This is the same example where I'm actually showing some control characters, so you can actually see over here now, okay, so this is a space, it's represented in a dot, this is a character, okay? And at the end of a line, I have a control carriage return or a line feed character, and over here I have a tab. Actually all of this are here, but you are not able to see them, okay? And over here there is an end of file character that is there, okay? That is not shown in this example, but there is something over there, so you can actually read all of this, and once you read the end of file character is going to be thrown out, okay? So all of these characters are there, but they're hidden from you so that it's easier for us to follow it, okay? So this is what we actually see, but this is actually what is stored inside a computer. So there are some hidden characters. So let's take this example, okay? So in this example, we have an end-of-file control loop. So we want to find the sum and average of scores of a class in a quiz. So suppose I have this file over here, and it has the score of one class, and I want to calculate the average and the sum of squares in this class, okay? So here's I'm going to start my program. So in my main program, I'm going to start, and in my main, when I start it, I'm going to be allocated a memory. And I am declaring a file pointer in file, so I'm going to make an in file. That is a pointer. Now again, this pointer is going to be assigned a value when we do an fopen, and we over here, and I'm going to use the small notations now, and I'm going to be declaring the score. So score is score. Okay, so this is my variable score, and I have a sum, and notice my variable sum has a value 0 as I declared it, and I have a value of an average. Okay, so I have an average, and what's happening over here, I come and say these are my double. I also come and declare it in count, so I have a count, and notice the count stays 0, and I have an input status, okay, with an underscore, and the input status is a variable, okay? Now, so I declared all of my variables, and this will be the memory space inside my main memory, okay? So the function with main, it has a memory, and inside it I have declared all of this file. I come over here and I say in file fopen score.txt. So the in file will be pointing to a buffer that will be pointing to a file. So I am just gonna go and skip the operating system in the middle and say that the in file is indirectly pointing to the score.txt file. Okay. Then input status is equal to fscanf in file %lf and the address of score. So I'm using the fscanf actually. I'm actually asking it to go read from a file called the in file. So it's going to follow the pointer, go read from it. It's going to read the 1.5 because I want a double. It's going to read the 1.5 and it's going to score it and put it into score 1.5. Okay, now it has actually read this number, so it's going to delete it, and now my cursor is here. So I'm going to read it. It's not going to delete it. It's going to jump to the next number. It's actually going to stay over here, and then I'm going to can go forward. I can never go backward when I'm reading a file. Okay, so it's going to put it into the score, and it's going to return in the input file, in the input status. It's going to put not end of file because I did not reach the end of file. Okay. So it returns, so the fscanf function returns for you, have you reached to the input on the end of file or have you not reached to the end of file. If you did not reach to the end of file, it's going to return for you a not end of file, and we are assigning it to an input status, so the input status will become not end of file. Then we come, while input status is not equal to end of file, so it is not equal to end of file, I am going to go and execute this statement. So in the printf, I'm going to be printing the value of score to the user. So you can actually see over here, I have printed the value of score, which is 1.5 to the user. Okay, and then a slash n, my cursor is going to come and stand over here. Then I'm going to say sum plus equals to score. So the sum, whatever value was in the sum, the value was 0. I'm going to add to it the value of score that I have read, so 1.5. So I'm going to delete this and I'm going to just make this 1.5. Okay, so now my sum is 1.5. Then I go count plus plus. Where's the count? Count was 0. It's going to become 1. And then I'm going to input status and I'm going to ask it to read for me one more number. So it's going to go and read the second number that is here, and then it's going to put it into the value of score. It's going to delete the 1.5 and now it's going to be a 3.5. Okay, now this is a 3.5 inside the score. I have reached the end of my while loop. I'm going to go and check. Of course, this is going to return for you and not end of file. So this is going to remain the same. So I'm going to go while input status not end of file. Okay, is it not end of file? Yes, it's not the end of file. So I am going to go and conduct this loop again. I'm going to read the other I'm going to print the score. So I'm going to be printing 3.5 now, and then I'm going to add the 3.5 into the 1.5 is going to become a 6.0 actually. So it's going to become a 6.0. It's going to be stored into the score, and the count will become 2 because I'm incrementing count by 1. And then I'm going to read another input. So I'm going to put the 2 inside my variable score. So I'm going to go into the score, and it's going to become 2. And then it's going to go and read the 10 and add it to the score, increment the count, and it's going to go and read all of these numbers until the end. And the last one, when it reads it, it's going to return a 10. So suppose we have reached the 10, and it's going to take the 10 and then go, because it's going to, when it read the 10, it's going to be not in the file. It's actually going to go inside and print it, add it to the score, whatever the score value is, and then add the count, whatever the value of count was, and then it's going to come and read the next one. Now the file has ended, so there is nothing over here. So now it's going to go and return for me. It's going to delete this and put it as an end of file. When this is an end of file, when the input status is not equal to end of file, it is the end of file. So this is going to become false. It's going to exit and it's going to continue. Now I didn't have space over here, so I continued the program over here. So it's going to go from here, shift to here, because this square was supposed to be at the bottom of this square, but due to the space limitation, I actually put it over here. So now I have to calculate the average. The average is nothing but the sum that I have accumulating divided by the count, because in the count I'm counting the number of students. So I can actually calculate the average, and then I can print this average to the user, and I can print the sum also. And then don't forget to close the file, and then you can put a system pause or return 0 to end your program. Okay, so notice over here what's happening is, as I go, how many times I'm going to go into the loop. Let's count those. So I'm going to read the first number, and then after that I'm going to do some calculation and read the next number, and every time I'm coming into this loop, I'm incrementing count by 1. So every time I read a number, I increment count by 1. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times. Okay, so count will have 15. And in each loop, what I'm doing, this command is making sure that whatever value that I have read, I add it to the sum, and I'm keeping accumulation, a record of what the accumulation value of the addition was. And when I reach the end of file, my sum will have the sum of all the grades of the students, and that is why I can actually print the sum of the grades, and then the average is nothing but the sum of the grades divided by the number of students. Okay, so this is how this program is working. So this is how you write in a file and read a file. Now over here, we did not want to write to a file, we just opted to print onto the screen, and this is something that sometimes happens. We take input from the files and print it on the screen. We sometimes take input from a file, put it in another file. Sometimes we take input from the screen and put it into the file. So we can do whatever we want. Any combination that you want, you can actually work on. The final thing that I'd like to remind you is that once you have read using the scanf, okay, so fscanf over here, once you have read it, you go to the next number, you go to the next number, you go to the next number. You cannot go back and read the previous number, okay? So it's always going forward. So make sure that when you pass a number, you are done with it before you read the next number, okay? Or what you can do is you close the file, and then you have to open the file again. If you open the file again, you will start from the beginning of the file, okay? Open it with a read, not with a write, otherwise you're going to delete the data, okay? And there's another example. If this was the score of the students, your program over here has to open it with an R. You cannot open it with a W, okay? Because you don't want to actually change any value of these. These are the grades the student get in the exam. They got it in the exam, and the instructor actually put them over here. So what you want to do is you want to read them, and you want to calculate the average. You don't want to lose this data, so you don't use a W with it, okay? Okay, with this we come to the end of our class. Thank you for watching me, and I hope I'll see you next time in the other class. Bye-bye.